Is it visible?
Yes, sir, it is visible.
Okay. So I'm going through some basic tricks like how we can calculate RMS value of the any periodic signal. So here I have written some periodic signals. Okay. The first one is the constant. So any constant will appear for any duty ratio. Here T is the time period of the periodic pulse. So for any duration, like see here, it is appearing here at initial only. At middle also, if it will appear for D into T, so U1 function I am defining. U is one function which I am defining. So for this type of signal, what is the U? U is V square. Okay. Any constant value will appear for dt time. Okay. Either it can be like this also. Let's say like this. This is the time period. And in middle also some dt is appearing. Dt some pulse is appearing. T is the time period. And magnitude is the V. So I am defining one function u. What is the value of u for this type of function? That will be v square. It means the square of the amplitude. Here amplitude is v, so u I am defining as v square. What will be the RMS value? So for all type of RMS, all type of signal, what is the RMS value? RMS is equal to under root u into d. So for this signal, I have defined u as v square. So what will be the RMS value? RMS will be for this under root v square into d. Okay.
And
Similarly,
what is
this
T?
which one? T is the time period. Okay. See,
And
this
D,
is
D.
D is the duty of the pulse means for this much time it is appearing. D varies from 0 to 1. Okay. D varies from 0 to 1. Duty ratio means on time. On means the pulse is appearing for this much of, let's say T is the total time period. D 0 to 1. So if D is equal to 0.5, it means this pulse is available for 50% of the time period. Okay. You got it? Let's say T is equal to 1 microsecond. Let's say T is equal to 1 microsecond. So if this will be 0.5 microsecond, what will be the duty? Duty will be this divided by this. So duty is equal to 0.5 micro divided by 1 micro. What will be 0.5? Is it clear? See, duty means for the duration for which the pulse is available. Okay. Is it clear to all?
Yes, sir.
Okay. Okay. So for this type of pulse, what is the u I am defining for different type of functions. Okay. So for this type of constant value, u will be v square. This you have to memorize. Okay. This thing you can note down. Otherwise, I will share the PDF also. Now you can take the screenshot because you have to solve some questions. So this you can take a screenshot. This formula you have to use next. Okay. So RMS will be in TD. For triangle also, different kind of triangle I have written here. Okay. For all kind of triangle, I if it is available for d duty times, so what will be the u for this kind of function? U will be v square by 3. For this kind of function, u is equal to v square by 3. Okay. So one thing you should know, either this will be positive or negative. Okay. Here it is positive. If it will be negative also, the u will be same because square will be positive. So let's say if this positive pulse is available like this, okay, below. This is dt. This is t. What will be the u value here? Let's say this is minus v. So u will be v square and RMS will be same. Okay. So for this type of function also, if it will be negative also, this u will be same. So what is the u for different kind of triangular wave? See, this triangular wave is like rising, this is falling, and this is rising and falling. So all have duty ratio dt, like on time dt. Okay. So for all this type of triangular wave, u will be v square by 3. Okay, is it clear to all? You can you
Sir,
can
this you.
you can verify all these things like by basic methods. Like you can calculate the slope of this graph. After the class, you can verify all the things. You will find the same answer. Okay, like you basic method you can go. RMS is equal to 1 by t. under root 1 by t 0 to t xt square dt. This formula you can use and you can verify all the answers. First you can solve by these short tricks and then you can solve by this basic method and you can verify the answer will be same. Okay. Is it clear up to now to all? Just you have to memorize this trick. Is it clear?
Sorry. Yes, sir. Please continue.
Okay. So this is one different kind of signal. The third one, all three will be same. So in this type of signal, some minimum and maximum value will be there. Okay. So for this first signal, minimum value is V1 and maximum value is V2. It is rising from here to here and appear for dt. Similarly, the second signal, here it will be falling. So V2 and V1. Here minimum and maximum value will be there. Minimum is V1 and maximum is V2. Okay. This is also appearing for dt and this is rising and falling. Okay. Here also minimum will be V1 and maximum will be V2. So this is the like this type of waveform we will find in more in the DC-DC converter. Okay. Like this will be the inductor current somewhere, this will be the switch current, this will be the diode current, like this type of waveform will come there. So what will be the value of u for this type of signal? Directly you can calculate u as u is equal to 1 by 3 v1 square plus v2 square plus v1 v2. This you have to memorize. U is equal to 1 by 3 v1 square plus v2 square plus v1 into v2. And for all type of signal, this formula only will work. RMS is equal to under root u into d. So for first one, what is the u? U is equal to v square. For triangular, any type of triangular wave, u is equal to v square by 3. And for this one, what is the value of u? U is equal to 1 by 3 v1 square plus v2 square plus v1 into v2. Is it clear up to now?
Sir, this you have calculated from the formula.
Okay, this u I am defining as one function. Okay, for this three type of waveform, u I am defining as one function. So for constant, what will be the value of the u? U is equal to constant square. Okay. For triangular wave, what will be the value of the u? U is equal to this peak square by 3. Okay. And here for this kind of signal, u will be 1 by 3 into this square plus this square, minimum square plus maximum square plus minimum into maximum. So this will be the u for this function. All three type of function you have to memorize. And RMS for all type of function, RMS is equal to, for duty ratio, the waveform will present duty ratio into u. So this will be the RMS value. Okay.
Is this formula applicable for that last problem also, sir?
Which problem? Like
last problem, that figure.
Which figure? Last figure also. Here also it will be same. For all three it will be same. Okay.
What is the value of d for that?
D. See D. How I am defining D? Again I am repeating here.
I got, sir, that d is a duty cycle. I got. So
okay.
We have to check the time period for this.
Okay.
Also.
This will be repetitive waveform. Okay. For this time period T, it is here. Again, it will start from here, same waveform. Okay.
So not for that one, the last one, the bottom one.
This one. Bottom. Okay. I will tell this one also. So see, this is the this is the combination. Okay. This is the combination of waveform. So in this, all three type of waveforms are there. This is this third type of waveform. Here constant waveform, and here only triangular waveform. Okay. So any random waveform will be there. How we can calculate the RMS value? So total, this is the periodic waveform. This is the time period. So RMS will be RMS 1 whole square plus RMS 2 whole square plus RMS 3 whole square. Okay. So this is the first signal. This is the second signal. And this is the third signal. So separately we will calculate RMS of all three signals. And what will be the final RMS? Final RMS will be RMS 1 whole square plus RMS 2 whole square plus RMS 3 whole square. Okay. So what is the RMS 1? RMS 1 is equal to U1 into D1. U1 we can calculate for this. Similarly, RMS 2 is equal to U2 into D2. And RMS 3 is equal to U3 into D3. Is it clear? Like any combination will be there. So separately we will divide all the waveform in different parts. Like this type of waveform is first one, second one is constant, and third one is a normal triangle. Okay. So different RMS square addition, and total under root will be the final RMS. Is it clear?
Right.
Okay.
And sir, what is the first sine wave, RMS value of sine wave?
Sine wave will be different. Okay. There, this type of trick will not work. We can analyze, but there it will be different. Okay. I tried for that one also, but there it will be different. You have to do that separately. So this is normally for this like a ramp or a square or this kind of waveform. It will be mostly in DC-DC converter. Okay. Sine wave also you can, but you should. I will recommend you for sine wave. So you should go by like basic. Okay. Sine wave also we can derive some tricks, but that will be not be universal. In some cases that will change. Okay. Like let's say, 1 second. Sine wave also, let's say this is a sine wave. Okay. Pi. Let's say full wave rectified waveform. Pi 2 pi. Okay. And here theta 1 and here theta 2. So if this will be like this waveform, this will not be there. This part will not be there, and only this part will be there. Okay. So you can derive any short trick for this one also. Like how you can derive 1 by 2 pi. Okay. Theta 1 to theta 2. This is theta 2. Vm square sine square omega t d omega t. Okay. Under root. So it will be Vm square by 2 pi. Okay. This will be 1 minus cos 2 omega t divided by 2 into d omega t. Is it clear? So see this part, see here, if it will be at same height, this part will be cancelled. Okay. So it will be Vm square by 2 pi. Okay. This is 4 pi, 2 I am keeping here, into this first will be theta 2 minus theta 1. This only it will be this sine 2 omega t by 2. So this theta 2 and theta 1, that will be, that part will be cancelled. So final will be this only. Okay. Is it clear? Like that you can
Yes,
derive
sir.
any standard formula and you can memorize that, like theta 2 minus theta 1 into this square by pi, and this term 1 by 2 sine 2 omega t. See 1 by 2 sine 2 omega t. This one for this one. So, this at this height and this height is same. So this resultant will be 0. So final RMS will be this one. So like that you can derive any standard and you can memorize that. Okay. Is it clear? Okay.
Yes, sir.
Okay. So coming to that part. 1 second. Okay. Up to now we have discussed. So now I'm going to give some questions. So this you can try first, second, third, and fourth. In every case, we have to calculate the RMS value. Already formula I have discussed, so you can try one by one and write the answer in the chat box. What will be the RMS for the first? See, for all time
Root over
period.
u into d. Root over u into d.
Okay, you calculate and tell what will be the final answer. What is the value of the u for first one?
3 3 is
Sir,
9.
3.
9.
9
It
by
is a
9 by
9.
3. V square by 3.
9.
So that will be
9
3.
into 0.4 root over, right, sir? 9 into 0.4 root
No,
over.
no. See, you will be V square by 3.
yes, sir, 3.
Okay, b square by 3. Okay.
Already you can take the screenshot. First formula you can take the screenshot already. For this one it is v square, for this one it is v square by 3. Okay, for this one 1 by 3 v1
Okay, okay.
square plus v2 square plus v1 v2. Okay,
Okay.
you can. So I will tell all of you, if you have doubt in this short trick, what you can do, you can like this, you can calculate by basic method, like y is equal to mx plus c. That equations you can follow. Okay. And still you have doubt, you can, I'll discuss the derivation also if you want in next class for this kind of formula. Okay. So see this, for first one, what will be the final answer? Anyone can reply? What will be the RMS value?
Into 0.4 root over 1.09.
Okay, 1.09. Correct. What will be the for this one?
This one 5 square into 0.3 root over 2.73.
Okay, correct. This one, for this one, RMS will be 2.73. Everyone getting the same answer? For this one, anyone can calculate? Third one?
Third one 1 square 1 plus 4 plus 4 divide by 3 into 0.4 root over 1.09 also.
You try once, maybe some calculation mistake you have done. What is the formula?
v1 square
U is
v1
equal,
square
U is equal to 1 by 3
hmm,
v1 square
v1
plus b1 b2 square plus b1 b2. Here 2 b1 b2 is not there. You have to memorize one thing.
sorry
This is
sorry
not 2
v1
b1
v2.
b2. Okay.
Okay, sir, got it. What is the problem? 1 square plus 2 square plus again 2 divide by 3 and then root over 1.52.
No, no, into 0.4 you have to multiply.
Okay, okay,
RMS is
then
equal to U into D.
u into
Sir,
d.
here what
Sorry.
is U? U is equal to, sir?
1 by 3 into
1
1 square plus
plus
2 square plus
4
1 into 2. Final will be 0.966. Is it clear to all?
What is the answer?
0.
0.966.
Yes, yes. This final answer will be
Okay.
the 0.966.
Hmm.
Everyone got the same answer? Now you can try the fourth one. See the fourth.
41 0.89.
1 second, I will also calculate. 0.89 you are getting.
Hmm.
Okay. Yes, correct. So already I told you either it will be negative or positive. Formula will be same. Okay. This waveform also it will be below. We will apply the same formula. So here it will be RMS will be 2 square by 3 with U into D. D is 0.6. So final value will be 0.89. Okay. So what all of you can do, you can try to solve all this question by basic method, then you will get more confidence. Okay. Initial point, you can assume anything. Let's say here this is 1. So let's say this is 0.1 and this is 0.5. Like that you can assume. This is 0.1 and this is 0.5. Okay. And by using the basic method, you can calculate. Here also you can assume the same. Let's say this first instant is 0.1 and this is 0.5. So duration will be 0.4. Okay. Here you assume 0.1 and 0.4. It clear? Again here you can assume 0.1 and 0.7. Is it clear to all?
Okay.
Like you can,
Okay, sir.
this instant value you can assume and you can try to solve is equal to, like this line you can write the equation. Okay. Why a straight line equation you can write and you can apply the basic formula and then you can verify the answers. It should match, both answers should match. Then only you will find confident that these short tricks are correct. Okay. Like how I am telling this is the method, but you should also verify that whether how it is correct or not. Okay. Okay. So I'm moving to the next question. Everyone up to now it is clear? Can anyone reply?
Yes, sir. Continue, please.
Yes.
Okay, okay. So this is one question. Okay, combination of all of you can try. I'll give you 3 minutes of time. So duty ratio already, I will give some trick. So duty ratio, what is the duty ratio? This is the total time period. Okay, duty is the duration of particular pulse.
Yes, sir.
Duration of particular pulse divided by total time, T, time period. Okay, so first one, what will be the duty? Anyone can tell? For first, this is the first waveform. This is the second waveform. This is the third waveform. After here, it is repeating the first. It means it is periodic waveform. Okay. So up to 20 milliseconds, this is one cycle from here to here. So can anyone tell me what will be the duty of the pulse, the waveform one? This one. What will be the
In
duty?
percentage. In percentage.
Hmm.
0.25.
0.25,
Yes, yes.
25%.
Okay, okay. So you can apply all the formula and you can try to calculate the final RMS value of this waveform. Okay. I will give you 3 minutes of time. All of you can try. If anyone is getting doubt in mid, they can unmute and ask.
Sir, for this wave, what is the U?
Okay, which one? Second. First one is the
Yes,
triangle.
sir.
First one is the triangle. Okay.
Okay.
From here to here it is going. So it means first waveform is triangle. What is the second waveform? See, first waveform
Sir,
minimum is
triangle.
0. Second waveform is 1 by 3 V1 square plus V2 square plus V1 V2. Okay. First one is the V square by 3. Second is the V square. Okay. Already here point I have marked. This minimum is 2 and maximum is 3. So this line is also 2. Okay. Is it clear?
Yes,
Okay.
sir.
Okay. You can calculate the final RMS value of this waveform. If you'll go by basic method, it will take too much time. Okay. So always
Yes,
you
sir.
should remember this short trick and you can apply anywhere. Like
8.30.
no, it's incorrect. You should apply that rule. Already I have told. Like here, see, for different waveform, you can calculate the RMS. Then what will be the final RMS? Final RMS will be the RMS 1 whole square plus 2 whole square plus 3 whole square. Okay. So here also we have three waveforms, three different waveforms. All for all waveform you should calculate U and D. Okay. Final will be RMS 1 whole square plus RMS 2 whole square plus RMS 3 whole square.
Sir, total will be RMS 1 whole square, RMS 2 whole square,
RMS
RMS
3
3 whole square.
total under root. Okay.
Okay.
Here duty will be 0.25. Okay. What will be the duty here for second one? It will be 0.3, I think. And for third one, what will be the duty? Duty will be 0.2. Everyone got this duty for all three waveforms? See, 5 by 20, first one. So it will be 0.25. Second one, 5 and 11. So what will be this here to here? 6. So 6 by 20. Okay.
Sir, 1.3 total answer.
This will be 0.3. I think I'm getting 1.66. Anyone got this answer? 1.66. Third will be
Sir,
11 and 15. So 3. 3 divided by, no, 11 and 15, it will be 4. 4 divided by 20 is equal to 0.2.
yes, sir,
Everyone,
same I got.
same you got. So I am going to calculate
Yes,
U value. U for 1. What will be U1? U1 will be V square by 3. So 3 square by 3. Is it clear? I think I have done some mistake maybe. How much you are getting?
Sir, 1.3068.
This U1 will be 3.
No, sir, U1 is equal to 3, huh?
3. What will be the U2? Anyone can tell? U2 is equal to 1 by 3.
9.5.
1 by
9.5.
3. 2 square plus 3 square
3
plus
square,
6.
6.
Is equal to how much? 19 by 3.
Yes, sir,
And
95.
U3 will be,
No, sir, 19 by 2.
okay, no, 1 by 3 na, here. 1 by 3 V1 square plus V2 square plus V1 V2. U3 will be this 2 square. U3 will be 4. So what will be the final answer? RMS will be, how much you are, 1.86 you are getting? Okay, I will also calculate. RMS will be U1 into, so RMS 1 will be U1 into D1. What will be the RMS square? RMS square is equal to U1 into D1. So simply we will multiply U1 into D1. So 3 into 0.25 plus RMS 2 square will be U2 into D2. So 19 by 3 into 0.3. And what will be the RMS 3 A square is equal to U3 into D3. So 4 into 0.2. Is it correct? Okay, let me calculate
Sir,
also.
sir, I have a doubt in this.
Okay, okay. Ask.
Sir, this U2 in U2, sir, the this denominator term will depend on the number of wave.
Which one? You can
Sir,
ask that.
this 1 by 3.
Again, ask again. Which one?
Sir, for this second wave,
Okay, second wave. Okay, this one.
the formula was 1 by 2,
No, no, 1 by
1 by
3.
2, I think.
It was 1 by 3. See here, 1 by 3.
Oh,
Already I have written here. No? It was 1 by 3. So only you should remember these three things. This is first one is V square, second one is V square by 3, and third one is this formula. Okay. So everyone is getting this answer 1.857.
सर RMS वैल्यू इन अंदर स्क्वायर करना है सभी प्रोडक्ट के साथ.
See, RMS1 is equal to already under root. Okay. What is RMS1? RMS1 is equal to under root E1 into D1. RMS1 whole square. This root will not be there. Okay.
Yes, sir, yes.
So it will be normal multiplication. A square root in separately, a square root will be there. RMS1 E1 in under root E1 into D1. Similarly for 2, U2 into D2. And 3 will be U3 into D3. When we will keep the square, so this under root will go and simply 3 into 0.25. Is it clear to all?
Yes, sir, okay, yes.
So all of you should memorize all these formulas, okay? And in DC-DC converter, it will be very helpful. or any in GATE exam, any other waveform, different kind of waveform they will ask, you can calculate within 1 to 2 minutes. See, if this question will be asked in 2 marks question, if you will go by basic method, then it will take more than 20 minutes. Like you will write the
Sir, I
equation,
got,
you got different answer?
sir, 1.06.
No, no. See, this you got duty ratio, first one, second one, third one, 0.25, 0.3, 0.2. This is
Sir,
first
correct.
waveform.
All correct, sir.
Okay, again U1 is equal to V square by 3. So 3 square by 3 is equal to 3. You got this one?
3.
U2 you got this one, 19 by 3.
Yes, sir.
And U3 is equal to 2 square. So 2 square will be 4. U3 is 4 you got?
Yes, sir.
Okay. So after this what we are doing? RMS 1 whole square, RMS 2 whole square, RMS 3 whole square. So this you have done 3 into 0.25
Yes,
plus
sir.
plus 19 by 3 into 0.3 plus 4 into 0.2. What you are getting the final answer? You can calculate again. It will be 1.857. Everyone is getting
Sir,
this
what?
answer?
Sir, I have already calculated under root U1, D1. Then I have separately calculated them.
You can try once. Let me calculate again. First, I will calculate without under root. What will be the value? So 3 into 0.25 plus 19 by 3 into 0.3. Okay. Plus 4 into 0.2. This I am getting as 3.45. Are you getting that? So under root 3.45, how it will be? How much? Everyone is getting this answer, 1.857.
Yes,
Yes,
sir.
sir.
You can check with calculation. Okay.
Yes, sir.
Okay. So now I am moving to one DC-DC converter question that is already asked in the gate. So we will explore the different RMS current of the different waveforms there. So this is the question. Okay. So first I am asking, everyone has gone through the boost converter. You know the concept, basic concept.
Sir, please continue. Please start with some basic.
Okay. See, 30 minutes of time is remaining, so I will try to cover some little bit. Okay.
Mm-hmm.
So boost converter, see, this is the inductor. So in any DC-DC converter, what we will do, we will apply volt second balance and ampere second balance. So what is volt second balance? Volt second balance means average voltage across any inductor uh, will be zero. Okay, and ampere
Average
second,
volt
average
and
voltage
average current
uh,
in capacitor is zero, right, sir?
and average current in capacitor will be zero. So see,
Yes, sir.
here plus minus VL, okay, and this is V naught. So I'm going to write the inductor voltage in on and off duration. On means this switch will be on, and off
Mm.
means, see, on means this will conduct like this, okay, and when this switch will be off, this will conduct in this path, okay. So I'm going to write the VL during on and off duration. So on duration, this is VS. So on duration, what will be the value of the VL? It will be same as VS. Okay. See here. This is the VS and this is the VL. And if this switch will be on, so what will this will be sorted. So what will be the value of VL? VL will be equal to VS. Is it clear to all? During on duration, this inductor voltage plus minus this is VL. Okay. Is it clear? Okay.
So
So
the BJT will either be in cutoff or saturation, sir,
yes, yes, yes.
right?
So if it will
Mm.
be on means it will be sorted. Okay.
Mm. Mm.
Sorted means this will be plus plus connected here, minus minus connected here. So what will be the inductor voltage? Inductor voltage will be same as the source voltage. Okay.
Mm. Mm.
You can write KVL in this loop.
Mhm.
This
Yes, sir.
loop
Yes.
is so VL will be VS. In second case, when this switch will be off. Okay. So when this switch will be off, what will be the inductor voltage? This will be source minus output. This diode will conduct. So across this, what will the voltage? Voltage will be Vs minus V naught. Okay. So we can draw the waveform. One second. One second. So I'm going to draw the inductor current, inductor voltage waveform. So this will be Vs, and this boost converter output voltage will be more. So Vs minus V naught will be negative. Okay. This is dt. dt means switch is on, and this is 1 minus dt. 1 minus d into t, and this is total time period. So dt means on period, 1 minus dt in when switch is off, and this is the inductor voltage. Okay. So when we will apply the volt second balance, means area under this curve should be 0. Okay. So how we can do one area dt into, let's say this is Vs, and this is Vs minus V naught. So dt into Vs plus 1 minus d into t into Vs minus V naught is equal to 0. What is this? This is volt second balance. So if you will apply this, you can get output voltage as Vo is equal to Vs by 1 minus d. Okay. Is it clear to all? Or should I explain again?
Yes, sir. Please
Sorry,
explain
explain
once
Clear.
again.
more.
Similarly,
So
if you
once
will
again explain.
want again explanation, see inductor voltage I am writing here. Okay. So during on duration, what will be the inductor voltage? This will be same as source voltage. Okay, here same as source voltage. When switch will be off, this will conduct in this path. So what will be the inductor voltage? It will be source minus output. This one. So here I have drawn the inductor voltage waveform. Again, I will write on the next page. So inductor voltage waveform during on time, this is Vs, and off time, this is Vs minus V naught. This duration is dt, and this is 1 minus d into t. So average voltage across inductor should be 0 according to volt second balance. So what is average voltage? 1 by t into area is equal to 0. It means area should be equal to 0. So we can calculate area here. What is the area for one period? This will be dt into Vs plus 1 minus d into t into Vs minus V naught is equal to 0. So I'm going to simplify it. See, dVs plus 1 minus d Vs minus 1 minus d V naught is equal to 0. Is it clear to all up to now this equation? How I have done? T I have common, means it will be cancelled and it will be 0. So this dVs plus 1 minus dVs, it will be Vs is equal to 1 minus d V naught. What will be the V naught? Output voltage. Output voltage is equal to Vs upon 1 minus d. Is it clear to all?
Yes, sir.
Okay. Similarly, you can apply the ampere second balance. So ampere second balance across this capacitor current. Okay. IC. So during on duration, what will be the value of the IC? Anyone tell?
I
This is
see.
I naught.
When it is
See,
conducting.
this diode will be off, so IC will be negative of I naught. Okay, switch will be on, diode will be off, but this load current needs some path. Okay, load current is following here I naught. So IC will be I minus I naught. Okay, so IC during on duration, IC is equal to minus I naught. Okay, again here this is IL. So if switch will be off, so this current will be IL, and what will be the IC during off duration? It will be IL minus I naught. So during off duration, this current will be IL minus I naught. Is it clear to all?
Not clear, sir. Please
Oh, okay, I will
explain once.
see here. This is the IC. Okay,
Hmm.
switch is on. Switch is on means this diode will be off. This will be off. Okay. This is the output current. So this side circuit is isolated. Means here we will see means what is the IC is I naught will flow through like this one. So IC we can say as minus I naught. Is it clear?
Okay. Yes, sir.
So same thing I have written here. IC is equal to minus I naught during on duration. And when switch will be off, this switch will be off. Then this inductor current will flow through this diode. Okay. So through diode, what is the current? IL. And here if you will apply nodal, so IC is equal to this IL minus I naught. Okay. IL minus I naught is equal to IC. So that I have written here. Okay. Is it clear?
Yes, sir.
So here also we can draw the graph. This is minus I naught. And this will be somewhat like IL will be triangular. So it will be like this one. Okay. This is the graph of the IC. So we can apply here ampere second balance. Ampere second balance means average current across capacitor should be 0. Okay, so how we can apply? Minus I naught into D plus IL minus I naught into 1 minus D is equal to 0. This means that average current across capacitor should be 0. So we can write as IL 1 minus D is equal to I naught D plus I naught 1 minus D. What will be D plus 1 minus D? It will be 1. From here we can write that IL is equal to I naught divided by 1 minus D. Is it clear?
Yes, sir.
So this is the like IL here is the source current also. We can see that this IL and source current are same. So we can say that if output current will be known, IL current will be output divided by 1 minus duty ratio. Okay. Now should I come to the question? What we have to calculate here? So can anyone tell whether it will be continuous or discontinuous? Can anyone reply?
Continue.
Sir,
What does it mean?
discontinuous.
Continuous or discontinuous?
See here inductor in gate question they have given 0. They have given 1 millihenry. Okay, I have changed that value to 0.1 millihenry. Okay, I have changed the value to 0.1 millihenry. So how we can decide that whether this will be in continuous or discontinuous conduction mode? Anyone can reply? Otherwise, I will explain. Will be continuous or discontinuous? Okay.
Sir, discontinuous.
No. So let me explain how we can decide whether it will be continuous or discontinuous. So what will be the output voltage here? See, duty ratio is 0.6. What will be the output voltage? Output is equal to 15 by divided by 1 minus 0.6. Can anyone tell what will be the output voltage? 15 divided by 1 minus 0.6. So this is
37.5.
37.5. See, this is 37.5 volt.
37.5.
Okay. So what will be the output current? Output current will be 3.75 ampere. Okay. So I'm going to draw the inductor current. Can anyone tell what will be the value of the inductor current with this information? 3.7 divided by IL is equal to I naught by 1 minus D. Okay. So 3.75 divided by 0.4. How much it will be?
9.3 something.
Okay, 0.4. So it will be 9.375. Okay. So this value will be 9.375. This is the average inductor current. Okay. So we can analyze the what is the boundary condition. Boundary condition means this delta IL by 2. 1 second. Delta IL by 2 should be equal to IL average. This is the boundary condition. Okay. If this delta IL by this IL average is greater than delta IL by 2, then it will be continuous. Okay. So little bit I am going to explain about boundary condition. What is the bound? So this is the inductor current in continuous conduction. Okay. This is the inductor current. At boundary, what will be the condition? It will just touch the x-axis. Okay. So this is the boundary condition. On time dt, and this is minus 1 minus d to t. Okay. This is the time period. So this is VL. VL is equal to, in on time, what will the value of VL? VL is equal to VS. Okay. So see, this is the delta IL, and average current will be in the middle of this. Okay. So if IL average is in middle of this one, it will be boundary of continuous and discontinuous conduction. And if delta IL by 2, if IL average is greater than delta IL by 2, then we can say that the converter is running in continuous conduction. Okay. So this is the boundary condition. How we can calculate delta IL? Delta IL means this one. Okay. From here to here, delta IL. So in this waveform, we can say y2 minus y1 divided by x2 minus x1. Okay. One formula, you know that VL is equal to L di by dt. Okay. And di by dt is equal to VL by L. So during on duration, what is the value of the VL? VL is Vs. So here what will be the slope? Di by dt. Di by dt means delta IL divided by dt. Y2 minus y1, this is y2, this is y1, this is x2, this is x1. So di by dt, we can write that delta IL divided by dt is equal to Vs by L. Is it clear? If it will not be clear, I will explain again. Is it clear? Anyone have doubt?
Explain again, sir.
Okay, okay. See, this is the inductor voltage. Okay, inductor voltage. This is on time. Okay, this is off time. 1 minus dt. Okay. So here, if this voltage will be across inductor, what will be the inductor current? It will be charging. Okay. Here negative voltage is applied. What will happen? It is discharging. So inductor voltage in steady state waveform will be like this. Okay. In some condition, this waveform will touch the x-axis. This x-axis. It is based on the value of the inductor and resistance. Okay. So this we called as the boundary condition. This is the continuous conduction. This is the boundary condition. So this is the inductor voltage during on time. What is the inductor voltage? Already I have written here. On time, the inductor voltage is Vs. VL is equal to Vs on time. Okay. So come to this waveform. Here I have written this inductor current is just about to continuous, means if charging and discharging just at total time period. Okay, charging start here, this is dt, it will discharge just at total time period. If it will discharge below this one, before this one, so it will be called as discontinuous. If it will discharge here only, let's say this is the time period, and if it is discharging here only, then it will be discontinuous. If it is discharging up to here, then it is boundary of continuous and discontinuous. Okay, so see, I'm going to calculate the boundary condition. So in this formula, you know, VL is equal to L di by dt. So di by dt is equal to VL by L. This I am going to apply during this on duration. Okay. So this is just boundary condition. So what will be the this di by dt? Di by dt means y2 minus y1. So this is delta IL. This is di. What is dt? Dt means t2 minus t1. This is dt. So delta IL by dt should be equal to VL by L. During this condition, what is the value of the VL? VL is Vs. Okay. Is it clear? Is it clear? See, so from here we can calculate delta IL. So for this question, I am going to calculate the delta IL. What will be the value of delta IL? Can anyone calculate from this data? What will be the value of the delta IL? Can anyone calculate delta IL for this one? Delta IL divided by dt is equal to Vs by L. Okay. what will be the delta IL? Delta IL is equal to dVs by LF. Can anyone calculate from this data? D is 0.6, 0.6 into Vs how much? 15 divided by L into F. L value how much? 0.1 millihenry into 25. So 0.1 into 25. How much this value? Can anyone tell?
3.6,
0.6,
sir.
0.6 into 15 divided by 0.1 into 25. How much? 3.6. So this ripple current in inductor value, how much we are getting? 3.6. Okay. What is the IL average? IL average, can anyone tell? IL average is equal to I naught divided by 1 minus D. I naught we have already calculated 3.75. Okay. So 3.75 divided by 0.4. How much? 9.375. Okay.
Sir, what is this 25?
Which one? This 25
Sir,
frequency.
25.
See,
Frequency.
T is time period. So if it will be, see, delta I will be d Vs T by L. So T will come in denominator. So it will be F. Okay. Here we can write delta IL is equal to d Vs T by L. So T I have taken in denominator. So d Vs by LF. Frequency is given here 25 kilohertz. Okay. Is it clear?
Okay, sir.
Okay. So
Done.
see here we can see that delta IL by 2 how much? Can anyone calculate delta IL by 2? 3.6 divided by 2. It is 1.8. Okay. So IL average we can see that IL average greater than delta IL by 2. So converter will be in continuous conduction mode. Okay. I'll draw one waveform. See, one second. IL we can draw like this one. Somewhere it will be like this. What is the average value? 9.37. This one, Lina. 9.375. So average value is 9.375. This delta IL how much? 3.6. So if it will be in boundary condition, means if it will be just touching, okay, then IL average will equal to delta IL by 2. When IL average greater than delta IL by 2, it is means continuous. IL average greater than delta IL by 2, then we can say that continuous. Okay. Is it clear? Once you will go through the video I will post it, then you can get it more. Okay. So I'm going to give little bit a hint how you can calculate. Okay. See, this thing you have to calculate. You can draw the waveform. Okay. First RMS value of the source current. Source current you can draw. Input resistance. What will be the value of input resistance? Input is equal to V by I RMS. Okay. This question asked in the gate. What will be the input resistance? It will be the V already 15 and I value I RMS you have to calculate. So I'm going to give some hint here how what will be the waveform shape. So source current will be like this. It will be like this one. Okay. What will be the peak value? Can anyone tell? This is 9.375 plus delta IL by 2. Okay. Here delta IL by 2. Here minus delta IL by 2. So what is delta IL by 2? Can anyone tell? 3. So 1.8. Delta IL by 2 1.8. So final source current waveform will be like this one. 9.375 plus 1.8. How much? 9 point. Can you calculate? 375 plus 1.8. 11.175. So maximum value will be 11.175. What will be the minimum value?
Sir, how
9.375
will
minus
you
1.
calculate this 11 point?
I will tell. This will be 7.575. This is dt and this is t. So with this is the inductor current or source current waveform. Okay. With this waveform, you can calculate the RMS, IS RMS. Okay, see how I am calculating. This is the inductor current. Okay. During on duration, this current will flow through source current. So inductor average current will come at mid. Inductor average current will come at the middle point, and delta IL by 2 we have already calculated, and here also delta IL by 2. So what will be the from here 9.375? So peak how we can calculate 9.37.5 plus 3.6 by 2. Okay, so that will be maximum value. What will be the minimum value? That will be 9.375 minus 1.8. So that will be 7.575. Is it okay?
Okay, sir.
Okay. So with this waveform, you can calculate by using that formula, you can calculate this one. So this is inductor current waveform. Okay. And further, what will be the diode current? Can anyone tell? Diode current waveform also I am going to draw. See. So diode will flow in 1 minus dt. Okay. So diode current waveform will be like this. It will start from here and this will go here. And period will be 1 minus dt. And this is t. The maximum will be same only 11.175 and minimum will be 7.575. Is it clear? So
Okay, sir.
you can calculate this one. Okay. In gate question, they have given 1 millihenry. So in case of 1 millihenry, the source RMS current was RMS and it was constant only because ripple was very small. See, if this ripple will be very small, so we can assume that as a constant. This ripple will not be there. Like it will be constant like that. It will be very less ripple. So they have assumed as a constant. Okay. Average current only they have taken this one, source average current, and this is the duty ratio. So they have calculated. You can check the final answer for that question, and you can calculate for this 0.1 millihenry also, and you can see the difference. Okay, is it clear? So now it's already I think 8. I have already given the enough hint for this one. See, theory part if I'm covering, it will be like for other people like covering the full question will be difficult. Okay. So you try to revise some like DC-DC converter, all of you should revise. I will mostly discuss question, that will be better. Is it clear? Like if you will come with some revision, then I can teach some new thing. Like already these things will be available. This basic thing will be available. So if you are covering this basic thing, then I can do some new thing. Okay. Anyone have any doubt in this question? Otherwise, we can close the session. Can anyone ask? Already I have given the hint what we have to calculate. You can take the screenshot of this question. You can try it at your own. So this value we have to continuous discontinuous. RMS value of the source current. What is the input resistance? Okay. RMS value of the switch current. So switch current will be the in positive half cycle. Okay. Is it clear? See, source current will not be like this one. I have done here some mistakes. Source current, if positive, it will be like this, and negative, it will come like this one. This is inductor current, source current will be like this one. Okay. Anyone have doubt? Again, I will draw the waveform. Otherwise, we can close the session. Is it? Anyone reply?
Sir, can you share this PPT?
PPT I will share. This PDF I will share. It will be shared with
Sir,
NP. Okay.
at
Hello.
which we can find this?
Are you there in the NPTEL one group is there? WhatsApp group?
Some EC and triple E group, that's one.
On NPTEL network analysis group is there. Like maybe you will be not be there. Okay, I will share
Okay,
with NPTEL team. Okay, NPTEL team I will share. They will otherwise next class, maybe some members are not there. In next class, I will ask them to add you there. You can drop your mobile number here in chat box.
sir, can you share the WhatsApp group link in the chat box? We will join.
Actually, I don't have that link. Actually, that is created by students only. They have added me there. Okay, so if you will drop your mobile number, I will send them to add your number. That will be better. Can you drop your number in chat box? Okay, 1 second. Okay, I will tell them to add you there. So see, this is at last I'm going to wind up. So this is the source current. Source current will be like here to here total. Source current and inductor current will be same. What will be the switch current? Okay, everyone have dropped their number. I'm going to take a screenshot. See, I'm going to give some hint how you can calculate. Here, source current. Once I will omit this one. Okay, but if I will do this, this thing will not come. Is it visible? Okay, see. Source current is the inductor current that will appear like this one. Okay, this is IS source current. Minimum, maximum. Already I have calculated. What is the switch current? Switch current only will be in first half. This is switch current, DT. This is T. This is DT. 1 minus DT. Okay, and this is switch current. And what is the diode current? Diode current will be in the only second half. So this will be like this. Minimum, maximum already I have calculated. So you can calculate the RMS value of all three quantities. And what is the input resistance? R in is equal to 15 by IS RMS. Is it clear? Can anyone reply?
Sir.
So you can use this waveform to calculate all these values. Okay. Okay. So now I'm going to close the session. We'll meet on the next Monday. So based on this concept only, we will solve some question.
Sir,
Yes.
sir, one
Sir.
question, sir.
Yes, you can ask.
Sir, is this a concept-based question or a previous year gate question?
This is previous year gate question only, but in this question they have asked only one thing. Okay. I am exploring the different things. Okay, which type of question can be asked further like that? That
Sir,
thing we
this
are.
is which year question, sir?
This is 2021. Okay, so there this value is very less. This value was too much less that we can uh, like make their approximation. Okay.
Sir,
Yeah. Yes. You
sir,
can ask.
this 1 minus d t. D is a duty and T is a time period.
Yes. D is duty. T is the time period. This total time period is T. Here also total time period is T. Is it clear?
Okay.
All of you can solve this question. I will come up with the answer in the next class. Okay. I will solve it and come up with the answer. So what you have to calculate? The source current RMS, switch current RMS, and diode current RMS. All three you should calculate, and input resistance. What changes I have done compared to the gate question? Just this 0.1 millihenry I have kept in place of 1 millihenry to make ripple more. See, if this ripple will be less, then then this will be a straight line. Okay. Due to ripple only, maximum minimum are coming here. Is it clear?
Okay, sir.
Okay, so all of you solve this question. Try to calculate the source current RMS value, switch current RMS value, and diode current RMS value. Okay, what else are given there? This much only we have to calculate. Input resistance also. All of you can take the screenshot of this question. Now, just get previous year, but 0.1 millihenry you have to take. I will come up with the answer in the next class. Then you can verify that answers. Thank you all.
Okay.
Thank you so much,
Sir,
sir.
we drop our numbers in the chat box. You may add us in
Okay,
that
okay.
group.
I have taken the screenshot, so I will ask them to add. 1 second, I
Yeah,
will check.
okay, sir. It's fine.
Any,
After adding, please send that
okay,
PPT or PDF of this
okay,
class
okay.
or
After
previous class.
reading only, I will share. Once again, Kivan, you can draw like write anything in chat box. I'm not able to see anything you can write.
Yeah.
Type anything in chat box. Okay, 1 second. I will take the screenshot of all the numbers. Then I will share in the group. After all of you will be added, then I will share there the PDF.
Sure,
Okay,
sir.
okay. Thank
Yeah.
you
Yeah.
also. So we'll meet in, so
Thank you so
I
much,
will
sir.
thank you. So I will tell you all of you should remember this shortcut tricks. Okay, whatever I am telling, all of you should remember. Then
Yes, sir,
in
sure.
in test series also you can solve any question in less time. Okay, so thank you all. We'll meet on the next Monday. I will come up with some good questions that day also, and we'll discuss some good things.